Alright, what is up everyone? I'm back and we here have MIT Integration B problem number 11 from the 2018 exam. We just finished halfway through the exam. In the typical exam, this would actually be, minute 11 of doing all these problems. You're seeing how many you can get done in 20 minutes. Um, I'm sure no one gets all of them, or I hope that I'm reasonably um, reasonably fast at solving these problems if I could just kind of sit down and do them. But I think that going through these at 4 or 5 minutes problem or even longer, I think that's always good. I'm just kind of seeing what that high level of math is going to be, and kind of noticing that um, we have the skills at the end of first year calculus or second year calculus to do the vast majority of these problems, especially when we have these really pretty and elegant solutions like we do in the MIT Integration B. So we have the integral of e to the x times 1 over x plus log x dx. So we haven't really ever worked with logs before, so log base 10, of course. But what we can do is we can rewrite that log as, see if I can move, there we go, move it over. We can rewrite log x as the natural log of x over the natural log of 10, right? Because log is base 10. And that's just your basic everyday rewriting logs as log base whatever over log base whatever as the x over the base. So I'm going to go ahead and do that. Because I don't like working with logs, I like working with natural logs. So we're going to write e to the x times, I'm actually going to switch these around for a second. The natural log of x over the natural log of 10. Right, that's log x plus 1 over x. All right, so now we have that. We've just rewritten the entire equation. It's perfectly fine. But I want to kind of be able to simplify these. So I'm going to multiply by a name for 1. So I'm going to multiply this by natural log 10 over natural log 10. So that's the same on top and bottom, so it's just multiplying by 1, which doesn't change any of the values. But now we have these two natural logs on the bottom, right? So what we can do here is we can actually move these both out of the entire equation altogether. So we can say that the entire equation is equal to 1 over the natural log of 10 times the integral of e to the x, natural log x, plus, and I'm actually going to go ahead and do 2 steps in one. I'm going to distribute that e to the x to both the terms inside the parentheses. And I'm also going to make 2 separate integrals by writing plus 1 over natural log of 10 times the integral, right? So this term carries on both the integrals. 1 over natural log of x times 10 plus distributing e to the x, e to the x, natural log 10 over x dx. And there's a dx here too. All right, so what we essentially did here is we distributed this e to the x in, we took that natural log 10 out, and then we made kind of 2 integrals, so one here and one here for both of those equations. So I'm going to work this right one a little bit first. We can take this natural log 10 out because the natural log is log base e, and 10 is a constant. And we can take it out, and those would both cancel. So we have plus the integral of e to the x over x, and I'm going to leave that there for a second. Actually, fun fact, the natural log, or the integral of e to the x over x, the integral of e to the x over x is actually has a name, and it's called the exponential integral of x. And that's kind of some advanced calculus we have going on there, and that's how you write it. But we don't have the tools right now to be able to kind of talk about how you evaluate it, or why you write EI, big uppercase E, lowercase I, instead of writing the integral, or how that represents, or what kind of it looks like on a graph. We don't need to get into any of that for the time being, but that's just kind of a fun little piece of information for your integral needs. Anyway, so we have this, and I'm kind of noticing you're multiplying two terms here, and I'm just going to go ahead and say, let's try parts. So I'm going to say u equals natural log x du is 1 over x, dv is e to the x, dx, v is e to the x. That seems simple enough. So now we have 1 over the natural log of 10 times, but the times is implied, so we have e to the x, not ex, gosh, e to the x, natural log x, so that's uv, minus the integral of v du. The integral of v du is that. There's a dx there, right? And we can bring this down. So we said that was just 1. So we're adding the integral of e to the x over x dx. And those cancel, which is absolutely amazing. And so now we are left with just this term here, which I'm going to rewrite up in this right-hand corner. So that is, let's see, that is 1 over the natural log of 10 times e to the x natural log x, or we can rewrite that still as e to the x natural log x over natural log 10, and that, because we know that we're writing the same base here, just as we did when we kind of simplified going from here to here. Now we're going back from there to there, or from that form, from the natural log over natural log form back into log base 10. We can see that's e to the x times the log, log base 10 of x plus c. Awesome. Good work, everyone.